Morning, everyone. Right. Any questions from the yesterday's class? Okay, let us start. Does anyone come across init scripts anytime? Does anyone come across init scripts anytime?
Yes.
What are those?
I mean, to start any daemons at boot time.
Right. While the system starting up, if at all that you want to start any application, or if at all that you want to run any script, you are going to keep under run level scripts. In the other way, which we will be calling as a RC scripts or init level scripts, init scripts. What is the purpose? When the system is coming up, okay, it is going to perform some tasks to make the things ready for your application. For example, if you take database, you will be starting the database when the system is coming up. Also, you will be running some scripts so that by the time that the database comes up, it should be ready, all the prerequisites. What you do for the same in your Kubernetes? If at all that you need to do these kind of things in the Kubernetes, how are you going to perform this? Any idea? Here, which we will be calling as an init containers. What are those? Init containers. What is the purpose of the init container? Before your main container ready, whatever the task that you need to complete, you are going to keep that as part of your init container, right? Let us see how to use this. If at all that you have a pod, right? This is the pod. If at all that you have the pod, okay, this pod is already having the container. Is that right? So this is going to be your container. Along with this container, you are going to keep a init container. Init container. So this init container is the one, for example, that you are starting the pod. So the first, it is going to start the init container. Very, very important. First, it is going to start the init container. And once this is successful, then only it can go to the main container. What will happen if it fails? What will happen if it fails? Your main container will not start. Are you getting my point? Guys, can you hear me?
Yes, Babu.
Yes.
So what are you? See, I told you, like, once the init container completes, then only it will go to the main container. That means till the main init container completes, the main container is going to wait. Okay, let us see how to create the init container. It is taking this much time to bring browser. Init container. Right? It is going to replicate the same requirement, however, that you have been following up. Let us create the pod with the init container. This is the pod. Inside this, you have the main container and also you have the init container, right? So init container is one part. Sorry, init container is one part and main container is one part. Even your init container is also of type an array, so that it's nothing but it's a collection of the init containers. That means you can have one or more init containers. If you go to the pod spec, I may need to stop little early today. I have office work exactly at 9. See, this is the containers. Can you see here? And along with this, you have the init containers also. This is the init containers. This is the init containers. Init containers is also type an array. Right. Let us create the pod. You are seeing the sounds of this bird. You are hearing the sound, right? That is of this bird. Pod init. Pod init. .yaml. If I create this, the main container will wait till the init container completes. But what is your init container doing? Can you see here? What is this init container doing? It is doing a NS lookup. NS lookup of my service dot the output of this. The output of this. What is the output of this? It is something like my service dot the namespace dot cluster dot svc dot cluster dot local. Here you are going to get the namespace, nothing else. So you are going to do the NS lookup of this service, and if you get the result, this init container is pass. What is the second init container? It is doing the same NS lookup of my DB service. My DB service. So once that is completes NS lookup of some domain name, it is going to get the output, right? So that is done. Once these two are done, then only the init containers is completed. Okay. So then only the main container will start. Let us try to create the pod. Right? kubectl get pod. What would be the situation of this pod? What is your expectation? What do you think? Will it be created or it will be waiting for something? What is the state of the pod?
Init.
What is that?
Init.
Init. What do you mean by init here? Have you ever seen this status till now?
No.
No. You are seeing it. Why? That's because it is having the init containers and the pod is not ready. It is waiting for the init containers to complete. How many init containers are there?
Two.
Two are there. How many of the init containers are completed? 0. Right? That's why 0 of 2. When it becomes 2 of 2, then it will start the main container. Once the main container is ready, it will become 1 of 1. Right? But whenever init containers will complete, whenever that it can see a service. Do you have the service? Do you have the service with these names? Do you have the service with these names? My service dot namespace dot svc dot cluster dot local.
No.
And no. If you can create them, it is going to be completed. Is that right? So let me create a service. What is the service name? One is my service, another one is my DB. Okay, let me create the service now. So two services, right? So once these services are created, automatically the NS lookup is going to work for that. Automatically the NS lookup is going to work for that. So that is the reason why you should see the init container status is done and your main container is in the running state. When you have more than one init container, it will execute in an order, not in parallel. Do remember the order that what you have defined in your pod spec, it is going to execute in the same order. In your environments, if at all that anything that need to be done before your main container ready, you can keep that as part of your init container. Where do you create the volume? Is it inside the pod or inside the container?
Inside the pod.
Right, you will be creating a volume inside the pod and you will be mounting that inside the container. Is that right?
Yes.
Volume, even it can be mounted inside the init container. Okay, so for you to understand this, you need to complete this exercise. What you do, you write a spec. This is pod spec. And you already know how to create the volume. Okay, so if you can try, you can try, otherwise you can leave it. You can create a volume in the pod spec. Okay, so here you are going to write init container, and here you are going to write the main container. You use the same volume here and you use the same volume here also. Okay, in the init container, you write a script. I mean to say command and aux. You can use that, and you can do a git clone in the mount path. Git clone in the mount path. That is the task of the init container. So when the main container starts, it will be able to see that cloned git repo. So you can make use of that repo from your main container. You can test this. Are you good with the init container?
Yes.
So where do you use it? The scenarios wherever it is required for your main container to get ready before it starts, you can introduce your init container. If you describe this pod, you will be able to see container session and init container session. In the init containers, you have init services, you have init mydb, right? What is the state of this container? What is the state of this init container? Terminated. Why? Why it got terminated?
Completed the job in lookup.
Because it has completed its task. You see the exit code 0. Exit code 0 means success. Is that right? See the second init container. What is the status of this? State of this? Terminated. What is the why it got terminated? Because it is completed its task. That is the reason why exit code 0. So once this is completed, it will execute in the sequence, not in parallel. Once this is done, then only the main container is going to start. Where is the main container? This is the main container. How many containers are there? 1. What is the container name? This one. What it is going to do? It is going to do some task. and it is going to sleep for this much time and it will exit. Right? How many images that you are using here? For every container or every init container, it is going to have its own image. Is that right?
Yes.
For example, if at all that you are downloading the repos or downloading the images from 2 repos, you have to place that image full secret even in the main container and even in the init container also. Do remember. Have you guys practiced yesterday's secret session? Creating a secret with Dockers, Docker login or Azure login, whatever it is. Have you? That is the most important one, because without creating the secret, you will not be able to pull the image. Any questions about the init containers?
Babu, usually this init containers, now I could see we are using the box image. So it will be in the real time, it will be only the service, or like, for example, it will have the database pod also inside this, means database container or image also inside this init container.
Repeat the question again, Naveen.
Okay, so now in the init container, we are calling this busy box application. So in the real time, as you said, the example is the database should be up before the application is up, right?
Database also can be
Yes.
deployed by using the Kubernetes.
Yes, but as the image of the database will be inside this, it can be inside the init container.
Why?
It has to be up, right?
Is it a long running, or is it an ephemeral?
Database.
Yes.
Yes, the database is going to be long running.
Then it should be part of init or main container.
Okay, yeah. In main container. Got it, yeah.
Right. So you should not confuse between the init containers and multi-containers. Right? Init containers are not part of the multi-container. You should remember that. Init containers are going to execute before your main container ready. Whereas multi-container means inside the main container session, you will be having more than one. And the second one, as I told you, as per the best practices, it should be loosely coupled, so that you should not run any two containers within the pod. Okay, only the supported containers, only the helping containers you should be able to run as part of the pod. In CKAD, they are going to ask the init containers, that's for sure. Be ready. Right. If you guys remember the first big billion day of Flipkart, what did you guys bought during that time? 2011, I think, right? 2010, 2011, I think. What did you bought during that time? Maybe that time Redmi is Redmi. There was another mobile from, I don't know, all the Chinese mobiles, one brand will be coming and it will bright like the Diwali things, and it will go away. That time some brand was there. People used to that is the, I think those are the days where people started buying phones from online. Till then people were not believing whether they are going to get the right phone, or it will be a cheated phone, we don't know. Right? So that time when the Flipkart coming up and immediately it is crashing. And again, when it comes back, again it is crashing. Have you you must have seen this, right?
Yes.
That's because, so when you are running your application, if your load is beyond your expectation, what should your application do?
The auto scale.
Autoscale. Just a minute, guys. So what they could have done from their end, there will be a load balancer, right? This is the publicly accessible URL, load balancer IP. In the backend, they might be having multiple backends. Multiple backends. Every time when the application is crashing, what they could have done? They could have done another instance, right? They will be bringing up the application. They could have done this. Okay, so you are guessing the load, assuming that since the load is coming, so they may hit this much load, but we don't know whether the load can permit to a single instance or it can even grow beyond this. We don't know, right? You cannot do this activity manually. You cannot do this activity manually. So what is an alternate for this? Auto scaling. Is that right? What do you do with respect to the auto scaling? You don't do anything. So you are going to keep an assistant where it is going to monitor the incoming load and it is going to increase the number of replicas in the backend. Is that right?
Yeah.
But what now we are in the container world. That time at least we are in the VM world. Now we are in the container world. You have to do the same even for your pods also. The same with respect to the container also. Okay, so in Kubernetes, you have a concept called auto scaling. Auto scaling. Okay, auto scaling can be done in two ways. Auto scaling can be done in two ways. Horizontal scaling. Horizontal scaling and vertical scaling. What do you mean by horizontal scaling?
Increasing the count of servers. I mean,
Very good.
containers.
Horizontal.
Vertical means for the existing container, we are increasing the memory and CPU or whatever resources.
Right, wonderful. So we have horizontal pod auto scaling and vertical pod auto scaling. Right, horizontal pod auto scaling and vertical pod auto scaling. With respect to horizontal pod auto scaling, you are going to increase the number of pods. And when you say auto scaling, the number of pods are going to increase or it can decrease based upon the workload that coming to your application. Is that right? Is that right? So what do you mean by vertical pod auto scaling? For example, you are running an instance. This is running with some capacity. Okay, now if at all that the load increases, it's going to increase the resources within that instance. That is called vertical pod auto scaling. Increase the resources means is going to increase the either CPU or memory based upon your configuration. Right? So here you need to understand few words. Scale up or scale down. Scale out or scale in. What is the difference? What do you mean by scale up and scale down? What do you mean by scale up or scale down? Good morning, guys. This is not a stock market word, commonly used word. Come on, what do you mean by scale up? I mean,
increasing the number of resources.
okay. What do you mean by scale out?
Scale out means like reducing it. Reducing it in case if it is not
Scale
large.
out. I'm asking about scale out.
Scale out.
Spreading.
Spreading, yeah.
Okay, scale up means this one. Scale out means increase the number of replicas. This is called scale out. Increasing the number of replicas. Scale in means reduce the number of replicas. Scale up means increase the number of resources on the instance. So now you tell me which is horizontal, which is vertical.
Scale up is vertical. Scale up and
Scale up,
are related to vertical.
Scale up and scale down is related to the vertical. Right? Vertical auto scaling, but in our case, since it is pod, we are going to say that it is vertical pod auto scaling. Vertical pod auto scaling. Right. With respect to the Kubernetes, we don't have the VPA. Only we have the horizontal pod auto scaling. Horizontal pod auto scaling. Horizontal pod auto scaling with respect to CPU, with respect to memory. Okay, you can configure both. You can configure only CPU for web-based applications. You can configure you can configure auto scaling based upon the memory for your database kind of applications. Right? So mostly when you, I don't know how many of you have a experience in working database or with database people. Most of the times, 90% cases, you will be seeing issues related to the memory only. Is that right?
Yes.
Either disk IO or memory.
Correct.
DISM, SM, ISM. I think you must have heard about these terminologies. Shared memory concept. Any one of you? Okay, you have to decide whether to go with memory based or the CPU based. As I told you, the web based applications mostly it is with respect to the CPU, right? Is that right? Are you getting my point? I am giving a hint. If at all someone is asking you to configure auto scaling, so to which one that you have to go, I am giving a hint. Okay. So with respect to the Kubernetes, we are going to have the auto scaling. Only HPA we have. Only HPA we have. Auto scaling. Horizontal pod auto scaling. This is a blog actually. Do remember guys, you are not supposed to open the blog or discussions in your certification exam. Okay, you are allowed to open tasks, docs, kind of, and reference, these three. Okay, go. Even though by mistake, if you open also, you will be disqualified. Do remember, while you are opening the URLs here, should be very careful. Let us go with horizontal pod auto scaling. You have to understand how this horizontal pod auto scaling is going to work. You are going to create the deployment called Amazon. And you are going to have the service for this. You are going to have the service for this. And you are going to create a horizontal pod autoscaler. This is another resource in the Kubernetes. Horizontal pod autoscaler based upon the CPU, assume like. So you are going to say that, hey, monitor this. Monitor this. Whenever. Okay, see, when I say monitor this means it's going to talk to the deployment only. Right? Whenever this deployment usage with respect to the CPU are touching some 50%, you increase the number of replicas inside your deployment. Is that fine? Can I ask like that or can I configure like that? Are you with me? Okay, so this is what that I'm going to do. But someone should be there to say, hey, your application using this much, your pod is using this much. Is that right? Who is that someone? Who is that someone? Satya, who is that someone? Siva, who is that someone who can monitor this? Or who can give, hey, you are using this much of the CPU, this much of the memory. Who can do that, guys? Metric server. If at all that you want to work with any auto scaling, definitely you have to have the metric server.
Okay.
Metrics server. If you don't have the metric server, you can't configure auto scaling. Clear so far? If you don't configure the metric server, your auto scalers will not work. Right. And on top of that, earlier, Kubernetes was using Heapstar, but Heapstar is not there. So now only metric server. You have to configure the metric server, and then only you will be able to configure your horizontal pod autoscaler. Here, your HPA is going to monitor your application for every 15 seconds. For every 15 seconds, your HPA is going to monitor your application, how much load it is using. This can be customized. And also, there is a scaling up time period. Scale up. It's called a cooling period actually. Scale up. For the scaling up, it is 3 minutes. For the scaling down, it is 5 minutes. Scale up is 3 minutes. Scale down is 5 minutes. Okay, so what actually the meaning of this? Scale up. For example, the load is increasing. It has to add one more pod for this deployment, right? Once the pod is created, it has to come up. It has to adjust the load. Then you have to again verify what is the average load. You means not you, that's the HPA job. Right? So based upon that only it can decide whether it still requires one more instance or not. Is that right? So all this time, at least it will take 3 minutes. That is the reason why scale up time we marked as 3 minutes, but this can be customized in your controller manager. There will be one option to modify that. In the same way, scale down. When the load is coming down, after business hours, definitely our load is going to come down. When it is coming down, so what is the cooling, what is the time interval that it has to monitor? For every 5 minutes. So it is going to delete the first replica. After deleting the first replica, to delete the second replica, it will wait for 5 minutes. If it is still seeing the less load, then only it will delete the second replica. Clear? This is called the cooling period. This is called the cooling period. Okay, but from certain version, they have removed this scale up cooling period. Okay, maybe some recommendations could be could have get from some of the clients. So they have they do not have the scaling up cooling period now, right? So if at all that you want to deploy the HPA, what and all that you should have? You should have the metric server ready, and also in your deployment you have to define the resources, how much of the resources that your pod requires. All these are mandatory. So let us configure one HPA. Can you see this? So you have a HPA. It is going to monitor the deployment. Okay, in between I have added the service because HPA will not directly work like that. Right. Now let us create. Okay, here to create you have both imperative and declarative. That is one good thing. Auto scale. Horizontal pod auto scaler. Right? You can come to this and take the spec and write maximum replicas. Range bound you have to define. So my range bound of my application is between 1 to 10, assume like. So at the most, this deployment can bring up to 10 instances. In the same way, at the minimum, if I define 3, it is going to bring 3. 3 means all the times it will be having minimum of 3 instances. Target CPU utilization percentage. How much of the percentage that you have to target? If I target it for 50%, so that based upon that result only, the HPI is going to react. And scale target reference, to whom that you need to monitor, right? In this case, we need to monitor the deployment. All these are the mandatory fields when you are creating the HPA. Okay, so let me show you how can we do this by using the command line kubectl auto scale -help. Let me create one kubectl auto scale deployment name. kubectl auto scale deployment name. Deployment name is assume like we have Amazon, right? Okay, Amazon, and you are giving range bound. Can you see the number of replicas range bound? And based upon what you are configuring this HPA, CPA percentage, and I will not be adding 80%. For me, it is 30% is fine. What does it mean? If the CPU percentage touches 30%, it should start increasing the number of replicas. Is that right? Is that right?
Yes, yes.
Yes.
Okay. So you can create just like that, or you can do a dry run. If you open this, so what is the target utilization? You have to remember all this. What is the target utilization? 30%, right? 30%. And whom you are watching? Come on, guys, you have to.
Amazon.
You are watching the deployment.
Yes.
What will happen if the load touches to 30%? What is that? Okay, till how many it can increase?
10.
Maximum 10, but one at a time, guys. If it is running with 2, okay, it can go to 3 and then 4 and then 5 like that. But as I told you, the cooling period is not there. It can grow based upon the load. If at all that you want to work with the autoscalers, make sure that you are running and your metric server is up and running. Is that right? How can I verify whether the metric server is running or not? How can I verify whether the metric server is running or not?
CTL get MS.
kubectl get.
MS.
Don't you use this command?
We didn't use.
Don't you use this command? What is the purpose of this command? And when it will start work? As long as your metric server is running, this command will work. Otherwise, it will not work. Is that right?
Yes.
Let me create. Will it work? Will it work?
We'll see.
Yes.
Yes, sir.
We don't know because I have applied it on the Amazon deployment. You have to verify whether the Amazon deployment is having the resources specified or not. kubectl get deploy. Can you go to the resources section of the container? Did we mention the resources? No.
No.
No. What will happen if you don't mention the resources? What is the limit range?
Minimum to max.
No, I am asking about the limit range. Can you repeat?
Minimum to max.
Limit range is that if you don't give the resources for your pod, automatically it is going to inject that resource limits in your pod. We have already discussed this, right?
Yes, yes, bro.
So do we have the limit ranges? kubectl get
Limits.
range, I think, right?
Limits.
Good.
Limit.
Limits only. Limits. Okay, so we do not have resource limits. So that is the reason why you have to configure this. Otherwise, it will not going to work. kubectl edit will not work for the resources because dynamic adding of the resources is purely based upon what operating system that you are using. Some operating system kernel will be allowed the dynamic resource management. Some kernels will not be allowed, right? It's not within the Kubernetes hands. It's the base kernel that you are using. If at all somebody is asking, you have to tell the same answer. Right. Let me do one thing. instead of Amazon, Amazon, let us create Amazon 1. I haven't created this yet. Before that, I should have the deployment called Amazon 1. kubectl create deploy. Deployment name Amazon 1 hyphen image is equal to Nginx. You have the resources. Increase, you define your resources. CPU. Okay, CPU you will be having again requests and limits, right? Requests. You can give like this. Requests. Okay, this is Volta. CPU requests 100 M. So let us create this. Let us keep the double quotes here. Right? We have deployment called Amazon 1. kubectl get deploy. Amazon 1 is running. How many replicas that it has? And how many are in running state? I mean, what are the number of instances and what is the position of them? 0 of 1. What is taking this much time? Are we using the same image? NGNX. Okay, it should come.
Yeah.
Now let us create the what is that? HPA. Can we create the HPA? kubectl top parts. If you see, Amazon 1 should show something. Amazon 1 should show something, right? It is showing. Now ls kubectl apply pod. What is the spec that we have created? Amazon HPA, right? Amazon HPA. kubectl get HPA. It will take some time to collect the metrics. What is the range? What are the minimum number of pods? 2 to 10. So by default, it should run with 2. Who is deciding this? Your HPA. Your HPA, the number of replicas that you have defined in your spec is going to be overwritten by the HPA. And in the HPA, whatever that you have configured, the minimum and maximum, so your deployment is going to have within that range bound. After some time, you have to get the present usage of your deployment. Otherwise, that means the HPA is not working. Can you get that value? Do you see the value? Right. If you don't see the value, your HPA is not working. It is very clear indication. Right now we have the HPA. Let us produce the load and verify whether we should be able to still see the number of replicas, whether they are increasing or not. Okay, so how can we do that? kubectl create service kubectl expose to what? Deploy / Amazon1 - port is equal to 80. Right? kubectl get svc Amazon1 service is of type cluster IP. Let me edit this. kubectl edit svc edit service name. Instead of the type cluster IP, let us change it to the node port. Shift R node port. Should I mention the node port name? Should I mention the node port name? Node port number? What is the range of the node port?
13,000 to
32,000 to
32,750.
767, right?
Yeah.
If you don't mention the node port, what will happen?
Take by its default port. It will take between the range.
So now, can I leave like this? Is that right?
Yeah.
Type node port. Okay, I think type node port will be also capital. Yes. Is invalid. Okay, now it is edited. Now you see that you are getting node port as this one. Right, 32598. Is it within the range? How can I connect to this service? How can I connect to this service? Go to your browser, use your IP 71, right? 71. What is the IP port? 32598. 32598. Huh? I think there is a space.
6 is extra. 32958.
Yes. Space also there. Let us read it. Can you see this? We are able to connect to the application. Okay, I want to generate the artificial load for this. How can I do that? There is a tool called sys. Let me install that. Apt-get update and apt install sys. Apt-get update. See, for example, when you are, I was telling you to practice because if you see here, when you want to perform this, how many of the things that you should know? You should know the node port, right? You should know the port range, and you should know the resources that how you have to provide, and you should know the metric server, right? You should know the metric server. All this and all require. And when you go to the next sessions, if you are not remembering the previous classes, you will not be able to understand them. That is the only reason that I was forcing you to practice. APT. So once we install the sys, then we can use that sys to produce the artificial load with respect to the CPU and memory. SIE. By using this command, I am going to produce the load so that the number of instances should increase. See, since I cannot give the load here, I am trying to produce the load artificial. Does that make sense?
Yes, yes. Still getting the load.
Right. Why it is taking this much time just to install the sys? Okay, it's done. I'm going to produce the load artificially by using this URL. So before doing that, that means I am not running that. Okay. Let me verify kubectl get HPA to verify whether there any increase or decrease within the replicas, right? Two range bound is 2 to 10, and at this moment it is running with the 2 replicas. Okay, let me increase the load. You don't need to do this step in your working environment, because you will be expecting a load by default. Now, if you see from the other browser, kubectl get HPA, you should see the load change. Right? Can you see that load has gone to 75%?
Yes.
Now it will start increasing the number of replicas, but not in a cooling period fashion. It can increase dynamically. See, now it is 4. Can you see the number of replicas to 4?
Yes, yes.
Is it working as expected?
Yes.
It will run for some time, because I have given the time there, how much time it should run. So whenever it's still increasing. When the CPU goes down, automatically the number of replicas is going to come down.
Come down to 2.
Minimum 2, right? Now the CPU is coming down. But cooling, while it is coming down, the cooling period will be applicable.
Yes.
It cannot reduce all of sudden, one by one. 5 minutes it is going to wait. Any questions? If you don't have any questions, please practice this and come. We have some more things to discuss regarding to the autoscalers. Right, guys? Bye for now. I have to switch to my office work. Bye for now. See you Monday. Please practice everything that you have pending. Ramesha, please practice this weekend and share me the screenshots. Siva, you too.
Okay, Babu.